Hello everyone and welcome back to our channel Quaint. Today's topic of discussion is digital signatures. When you log into your bank account or sign an online document or send an important email, how does the system know it's really you and not a hacker pretending to be you? So this is the problem. And for this thing, scientists have developed digital signatures. It is almost like a handwritten signature. Okay, you know the purpose of handwritten signature. Similarly, why digital signatures are used? To verify who you are. Means it verifies your identity. To verify who you are and confirms what you approved. That is the purpose of digital signatures. Actually, digital signatures use the power of cryptographic algorithms to ensure three things. Number one is authenticity. That means the message really came from you. Next is integrity. That means the message hasn't been changed or altered. That is integrity. And point number three is non-repudiation. That means you can't deny signing it later. So, digital signatures ensure all these three things: authenticity, integrity, and non-repudiation. Next is, how does this actually work? So, suppose when you create a digital signature, your device or your system has a private key. It's a secret number known only to you. And your system actually uses this secret number or this private key to generate a unique mathematical code from the message you are sending. And this unique mathematical code is attached to the message you are sending. Okay, and the recipient who receives it, the recipient of the message who receives it, they can verify the message, your message. They can verify your message using public key to check what? To check the authenticity and the integrity of the message. So this way digital signatures work. And this is known as actually public key cryptography. Public key cryptography, and this this cryptographic technique uses different algorithms like RSA, DSA, ECDSA. Anyway, these things are used over internet for the purpose of security, to secure everything. Okay, and everything means what? That is known to you. If it is not secured by using these digital signatures, then everything would be at risk. Your identity, your bank transactions, national secrets, many things are there which would be at risk. Okay, if digital signatures are not used. So actually digital signatures, these things rely on mathematical problems which are easy to perform in one direction, okay, but very difficult to reverse. Like RSA, if you talk about RSA algorithm, then in that case what is used? To generate the key, very large prime numbers are multiplied. Means in RSA technique, they multiply two very large prime numbers. That is easy. That is easy, you know, that is easy to generate the private key. But factoring that product, you have already multiplied two large prime numbers, so factoring that product back into the original prime numbers, that is very difficult. Even the fastest classical computers would take millions of years to solve this, to break this. So you can see, this is so difficult. That means hacking becomes so difficult when digital signatures are used, because they use this type of mathematics. This was just an example. Many more mathematical puzzles are there which are being used by different cryptographic techniques or digital signatures. This was just an example. So this one-way difficulty makes this digital signature possible actually. We can easily trust on these things. So this way actually digital signatures work, but there is a problem. Quantum computers are coming and they use qubits instead of bits. Classical computers use bits and they use qubits. So a quantum computer actually thrives on parallel computation. And source algorithm is there, which can which can factorize very large numbers so fast that if you make a comparison, then using source algorithm on quantum computers, you can factorize any large number within seconds. And if you talk about those classical computers, even the fastest supercomputer on Earth, then that would take millions or billions of years. But by using source algorithm on a large enough quantum computer, you can do the same thing within seconds or minutes. That means using quantum computer, hacking would become very easy. So what is the requirement right now? Right now requirement is to change these cryptographic techniques for digital signatures. RSA, DSA, ECDSA, okay, so many algorithms are there. So we need to change those things. That means we need new cryptography techniques. And one such example, and that is actually very famous, CRYSTALS-Dilithium. CRYSTALS-Dilithium, and that has already been approved and declared by what? The US National Institute of NIST, means Standards and Technology. Okay. Anyway, so scientists and researchers are working on this new cryptographic technique. One such example is CRYSTALS-Dilithium. Okay. So this new technique is required. If you do not use, if scientists do not use this technique, then just after the discovery of quantum, not discovery, actually quantum computers have already been discovered, but there is no widespread use of this technology right now. That's why still you are safe. Okay, means your transactions are safe, your online activities are safe still, because hackers are not using right now quantum computers. But if in the hands of hackers quantum computers are there, then new cryptographic techniques or quantum cryptographic techniques are required for the same thing, that is digital signature. Anyway, so this was all about today's topic. This is the end of this video. If you found this video fascinating, so please like, share and subscribe to our channel. This is the end. Thanks for watching.